Welcome back. Today we're going to look at an example of how to add vectors using the tip-to-tail method and the law of sines and the law of cosines. First, I'd like to begin by discussing the law of sines and law of cosines, as we have not touched on that yet. Allow me to start by drawing a triangle here for reference. We will use lowercase letters to denote side lengths, and we will use capital letters to denote the angle opposite of that side, as such. So now we can write out the law of sines. Which states that the sine of the angle A over the length of A is equal to the sine of B over the length of B, which is equal to the sine of C divided by the length of C. And then we also have the law of cosines, which states that the side length C squared equals A squared plus B squared minus 2 times A, B, cosine of C. Now, with that out of the way, let's look at our problem statement here. The problem says to find the magnitude and the direction of the resultant vector FR, which is not drawn yet. And then we're given the values of F1, alpha, F2, and phi. Now let's add these vectors using the tip-to-tail method to find the resultant. If you remember, these vectors can be added in either order. I will start by drawing the horizontal here. Then we will start with F1, and that one, if you remember, was length 3. And then we have F2, which was 5. And now we can draw our resultant, which would go from the tail of F1 to the tip of F2. So this would be FR. This is F2. This is F1. Whoops. F1. Remember, this angle here was 25 degrees. And the angle here, let me make that green. The angle here was 50 degrees. And so we know that this angle would be 25 degrees because it is an alternate interior angle. That's just from geometry. So what we're trying to find is the magnitude of FR and also this angle here, which I will call theta. So now we have a triangle, and we know two sides and one included angle. If we add these two together, the 50 and 25, we know that that angle here is 75 degrees. So we can use the law of cosines to find the missing side length, which would be FR. So if we look back here, this here is our equation for the law of cosines. This would be our FR, this would be F1 and F2. So plug that in. We have FR squared equals F1 squared plus F2 squared minus 2 times f1, f2 cosine of this angle here is 75 degrees, which is opposite of FR. So plugging in the values, FR, if we take the square root of both sides, FR is the square root of F1 is 3, so 3 squared, plus F2 is 5, so 5 squared, minus 2 times 3 times 5 times the cosine of 75 degrees. If we solve the inside, we get FR equals the square root of 26.2354. Punch that into a calculator. The magnitude of FR is 5.1221. However, we don't want that many decimal places. We will just use 3 significant digits. So we can write FR equals 5.12, and if we remember the units, so we need to make sure to add those. So that's the magnitude. Now, all we need to find is theta. Let me go ahead and copy this. Okay, so now I've copied this over here. So before we can find the angle theta, we have to first find this angle in here. Let's call that angle gamma, because that's the angle that's actually inside of the triangle. So we can use the law of sines to find this angle gamma. Since we know all of the side lengths now, and we know one angle, and we want to find another angle, so using the law of sines, we can write the sine of 75 degrees, and then the corresponding side length for that, which would be FR, which we found, let me just write FR, would equal the sine of gamma over the corresponding side length for that, which would be F2. So now we can cross multiply to get F2 times the sine of 75 degrees equals FR times the sine of gamma. Plug in the known values for F2 and FR. We get 5 times the sine 75 degrees equals 5.1221. I'm using the full value of that again so we don't carry our rounding error, times the sine of gamma. So our only unknown now is gamma. So let's divide over the value of FR, 5 times the sine of 75 degrees over 5.1221 equals the sine of gamma. Take the inverse sine, of this whole expression, 5 times the sine of 75 degrees over 5.1221. We end up with gamma equals 70.5 degrees. However, we are looking for theta, and theta would be equal to gamma plus that 25 degrees that we have down there. So theta equals gamma, which is 70.5, plus 25. So theta equals 95.5 degrees. So there we have it. We've now found the angle theta, which is the angle of our resultant, and we found the value. So the resultant force goes, actually I drew it a little bad. It should have been past 90 degrees a little bit. Resultant force comes up here, 5.12 kilonewtons at 95.5 degrees from the horizontal. Thanks for watching. If you enjoyed this video, consider subscribing to stay up to date with all of my latest posts. Comment down below any thoughts or questions you may have. See you next time.